Alright guys, we're all done with chapter 6 and we're going to move on to chapter 7. Chapter 7 deals with exponents and rules with radicals and a lot of different things like that. Now, the very beginning of chapter 7 we talk about different types of exponents, and in 7.2 and 7.3 we're going to talk about more rules with exponents that maybe you've seen before, maybe are brand new to you. In all likelihood they're probably brand new. But today we're going to just talk about zero exponents and negative exponents. Before we do anything, let's take a look at some stuff you probably already know. You should know that the expanded form of 3 to the third is 3 times 3 times 3. You studied this in chapter 1 with Mr. Lankus. 3 times 3 is 9, times 3 is 27. Okay? And you should know that negative 2 squared, how to do that. Now something important, I do this problem on purpose, is you should notice the negative sign is not part of the squared. You might think that that's negative 2 times negative 2, but it's not. It's a negative, and then it's a 2 times a 2, and that's how that works. The negative does not get applied to the 2 times the 2. So you do 2 times 2 is 4, and you bring down the negative on the outside. We can talk about that more as to why that's technically what the answer is if you have more questions on it tomorrow. 2 to the 5th is, 2, 2, 2, 2, 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now what I want you to notice, block that off, what I want you to notice is the next one, the negative is part of the exponent because it's in parentheses. So what that means is that we do have the negative sign with the 3 each time. So negative 3 times negative 3 times negative 3 is negative 27. In this next problem, again, the negative sign does get the squared, so we do negative 4 times negative 4, and that's a positive 16. So there's a really big difference when the negative side's in the parenthesis versus when it's outside. And 6 to the first is just 1 6, so it's just 6. So those are some good warm-up problems. Today you're going to learn about exponents, like I said, that are negative or that are 0. Here's the basic mathematical rule. Anything to the 0 power is equal to 1. So for example, 3 to the 0 power is a 1. Okay? Something you might not get though, let's try this one. Let's try another easy one. 4 to the 0 power is 1. Now watch this. If you have a negative sign and then 4 to the 0 power, you do 4 to the 0 power is 1, that negative sign travels out front because that negative sign was not part of the 0 power. Now if you have the quantity negative 4 to the 0 power, that negative does get the 0 power, so that's a positive 1. And that's the rule about anything to a 0 power. Moving on. The second rule today, so there's your first rule. Second rule today, anything that has a negative power needs to be on the opposite side of the fraction. Now that's how I state it. I will tell you, there you go, on the opposite side of the fraction. I will tell you that the book's going to state it like this. Anything to a negative power needs to become 1 over that answer. And honestly, 1 over that answer means that it does need to flip to the other side of a fraction. Let me give you an example, okay? Let's do a very basic example. If you have 2 to the negative 1 power and 3 to the negative 2 power, you see how those have negative powers? That doesn't mean that this becomes negative 2, and it does not mean that this becomes negative 9. What it means is that the 2 needs to go to the bottom, so its power can be normal, and the 3 needs to come to the top, so its power can become normal. Okay? That's going to give you a 9 over a 2. Let's try another one. Okay, I'll make this one a little harder. If you have a 3 to a negative 3 power, and you have a 2 to a positive 3 power, here's how you fix that. The 3 is the only one that needs fixed because the 3 is the only one with the negative exponent. So when we move it to the bottom, we get 3 to a positive 3 power now because it's where it belongs, and 2 to that 3 power that it already was. Now you might ask, well, what's it under? It's under a 1 now. If it's not, nothing's left in the numerator, it reduces to a 1. So that's 1 over 27 times 8, because 3 to the third is 27 and 2 to the third is 8. So that makes 1 over, let me find my calculator, 27 times 8, 216. Okay? The only other one maybe I'll show you is pretend you have 1 over 5 to the negative 1 power. The 5 is not happy on the bottom. He needs to move to the top. So it becomes 5 to the positive first power times 1. I essentially don't need the times 1 because times 1 is just, itself. There's nothing on the bottom, so I don't have to write over 1 when something's not on the bottom. So my answer is just a 5. Okay? So in this example, we got an answer of 9 over 2. In this example, we got an answer of 1 over 216. And in this example, we got an answer of 5. All right? This applies to negative exponents of variables as well. I'd like to give you a couple more examples, maybe some with variables. Pretend you have 3 to the second power, 7 to the 0 power, and x to the second power. Well, you know 3 squared is 9. You know 7 to the 0 power is 1. And x squared is just x squared. So this final answer is 9x squared, because 9 times 1. Let me try another one with you. Okay, let's see how you do with your negative powers. Pretend you have 2 squared n to the third, and then on the bottom you have an m to the negative 5. Well, we do know that 2 squared is a 4. The n is positive, so it's happy where it is. And you see the m down here? It's not happy where it is. It needs to move up top. M to the 5th. Technically, there's only a 1 in the bottom, so we don't have to write it. And one more technicality. In math, we tend to write things in alphabetical order. So I'm just going to rearrange it. This is acceptable, so this is okay, but this is the best answer. We have a lot more examples to come. I put this chart on here for you because it really does sum up all the rules of the exponents that you're going to be learning throughout 7.1, 7.2, 7.3, and then applying in the future future problems that we'll be doing. Today we're focusing on the 0 power problem and the one where we have an exponent that's negative. Okay? And they give you really nice little examples over here. We'll be applying other things later, okay? You're going to be learning these other rules as we go along. And we're kind of learning this one down here today as well, okay? It's the negative exponent. Let's go ahead and move on to problem 1 and see how you do. Try it. What is the simplified form of each expression? You can give it a try. You can pause the video. I'm going to keep going. Well, I see that this has a negative exponent, so I know it's not happy where it is, so it needs to go to the bottom of the fraction. So I know that technically it's over 1. I hope you understand that. So it goes down to the bottom. 9 now has a positive exponent of 2. It has a 1 in the numerator because if nothing else is left in the numerator, it's a 1. So we get 1 over 81. Okay? I will expect to see this step because it's very easy to do in your calculator and try to kind of slide by. So I will expect to see that step to show me that you have got the understanding that you need. In part B, I noticed the negative sign and the 3.6 has a 0, and your rule today is anything to the 0 power is a 1. That one really doesn't require a lot of work. Let's try the got it. Again, you can pause the video, try them yourself, and then see if you make any mistakes. It's probably the best way to learn. Okay, we have 5 problems down here. The 4 is not happy in the numerator, so I have to make it 1 over 4 to the third power. And I know 4 to the third power is 4 times 4 times 4. That's a 64. Okay? Part B, everything is to the 0 power. Since everything's to the 0 power, my answer is 1. Part C, the 3 is not happy on the top, so it would get moved to the bottom. So that's 1 over 3 to a positive 2 now when it moves, and that's 1 over 9. Letter D, again I see that ugly negative exponent, which means 6 is not happy in the numerator. Technically it's in the numerator. So I do 1 over 6 to the first power, which is simply 1 over 6. And then the last problem. I'm going to notice that the negative sign and the 4 have a negative 2. So that means that my negative sign and my 4 need to move to the bottom. My 2 becomes positive now, and I know that's 1 over negative 4 times negative 4, which is a positive 1 over 16. Alright, let's try it again. Problem 2. We got a little more difficult ones, right? Check out if there's anything wrong with problem A. What is the simplified form of the expression 5a to the third b to the negative 2? Well, I know that I'm not supposed to have negative exponents. That means the b is not happy where it is, so it needs to move to the bottom. The 5, the a, and the 3 are fine, but the b squared needs to move to the bottom. Make a note to yourself that 5 is not 5 to the third. Some people think that, Some people think that 3 applies to the 5. The 3 is only for the a. So please don't make that 125 a to the third. Alright, the next one. Do you see your negative exponent? It's not happy in the denominator, so I move it to the numerator. Essentially, I get 1 times x to the positive 5 now when you move it. Well, that's just x to the 5th. Alright, why don't you try the 5 problems, pause the video, and then start the video again to see if you get it. In part A, we have x to the negative 9. It's not happy where it is, so I have to put it on the bottom. In part B, I have 1 over n to the negative 3. The n is not happy where it is, so I get 1 times n to the positive 3 over nothing, essentially, or over 1, which is simply n to the third. In part C, I see that the negative 3 only applies to the letter C, or the variable C. So the 4 and the b are happy where they are, but the c needs to move to the bottom to become positive, or for the exponent to become positive. Letter D, the a has the negative exponent, so we need to move it to the top. We need to trade places so it becomes happy or positive. So we get a 2 times a to the positive 3 now, which in math we just write 2a to the third. Please do not make the assumption that the 3 is for the 2. The 3 is only for the a. And then letter E. The n is the only one that's not happy, so we throw it on the bottom. That leaves a 1 in the numerator because you can never just leave your numerator blank. Okay? The m stays where it was, so m squared. And the n joins it now, and you get n to the 5th. Alright, hopefully you did a nice job on those problems. On problem 3, I'm going to pause the video and then I'll start a new one. But if you want to at least try getting it set up before you move on to the new video, it might be a good idea. We're going to evaluate now. When I say the word evaluate, you should know that means that you're going to plug stuff in and you're going to simplify. Okay? So plug stuff in and simplify. I'm going to start my new video.